In this next lesson, we'll look at two more ways to solve a system. You already know how to solve a system by graphing, and you know that the limitations of that come into play in that answer that you get is an estimate, and it's really difficult to work with if your solution happens to involve decimals or fractions. So the two examples that we're going to look at today are going to use other methods that are more exact. The first method is called the substitution method. These steps are going to seem a little bit confusing when you write them into your notes until you see an example. But the first step to solving a system by substitution is to pick one of the two equations and solve it for one variable. If you have a coefficient of 1 or -1, that's the one you should work with because your calculations will end up being easier if you do that. Once you've got that one system, so one equation solved for one variable, you're going to plug that expression into the equation that you did not use. And then that will leave you with the solution to one of the two variables. Finally, you'll take that solution, plug it into either of the original equations, and then that will give you the other variable solution. So let's take a look. Our system is 3x plus 4y equals -4 and x plus 2y equals 2. Step 1, again, was to solve one of the two equations for one variable, and if you happen to have had any of the coefficients being 1, that's the one you should pick. So our second equation, the x, has a coefficient of 1, so that's what we're going to be solving for. We're going to be using inverse operations to solve for the x in the second equation. Okay, that was our first step in the substitution method. Step 2 was to take that expression, so the value that x was equal to, the 2 minus 2y, and plug it into the other equation. So, for our step 2, rather than writing 3 times x plus 4y equals -4, when I get to the x, I'm not going to write the x, but I'm going to write what x was equal to, which was 2 minus 2y. From there, I'm going to solve this like I did earlier in the year. So I would distribute and then combine like terms. And then use inverse operations. Here I would subtract 6 from both sides, and then divide both sides by -2. And now I've got half of my solution. Remember, for a system, my solution is an ordered pair, x comma y. I now have the value of y. Step 3 is to take that value of y and plug it back into either of the original equations to solve for the other variable, which would be x. So I can either pick the 3x plus 4y equals -4 or the 1x plus 2y equals 2. It really does not matter which one you pick. You'll get the same answer either way. The numbers are a little bit smaller in the second equation, so that's the one I'm going to pick. I'm going to plug in the 5 for y, since I know that is what y is now. And simplify and solve for x. My final solution to a system is an ordered pair. So I'm going to write my system as an ordered pair, x comma y. X is -8, y is 5. So our final solution is -8 comma 5, that ordered pair. You will like to get in the habit of doing checks. So going back to the original problem and plugging in the ordered pair -8, 5 into both of the original equations will help you verify whether or not you got a correct answer. So my original problem, the 3x would become 3 times -8. The 4y would become 4 times 5. And I want to simplify that to see if I get -4. And I do. So that checks out for the first equation, and I also need to check it for the second equation. So my second equation, rather than x plus 2y equals 2, my x was negative 8. Instead of 2 times y, my y was 5. And then I'll simplify this. And that also works out. So I know that my answer is correct.